I'd like to begin with a review of significant figures. Probably are really good with these by now after working through the activity. But just take a few moments to practice A, B, C, D, and F to make sure you are up to speed. The strategy will be to look over those rules of significant figures. The big thing is how zeros apply. For your answers, you should get 3 significant figures for part A. All 3 of these are non-zero. They are all significant. For part B, 4 significant figures. This 0 is sandwiched, and it is significant. And then all 4, any non-zero digit is always significant. Part C, 3 significant figures. The leading zeros are not significant. 3, 5, and 6 are. Part D, we have 4 significant figures. These are zeros that are after a decimal place, after a non-zero number. They are significant. Don't worry about the exponential. Notice if you just look at the portion before, you can still get the correct number of significant figures. Part E. While this table does say it's ambiguous, if we follow the rules, we should just get 1. This is a 0 that's trailing. There's not a decimal place. It's not significant. The 5 is. The most correct answer is 1. Part F. This will be 4 significant figures. The 0 after the 5 is after a decimal place and after a non-zero digit. That is significant. The 0 in the front is a leading 0 that's not significant. Once you have a good handle on significant figures, you can apply that to arithmetic operations. Have a handful of examples here. Going to work out A and B together, then C and D, and last we'll look at part E. You'll want to still remember and apply the rules for significant figures in calculations. You'll also want to know how significant figures affect addition and subtraction, and how they affect multiplication and division. For addition and subtraction, you will look for your value that has the lowest number of decimal places. Comparing these two values, the first value has 1 decimal place. Our ultimate answer has 1 decimal place. When you add these together, you'll get this value, but you will need to round it. The rules for rounding is whichever value you need to round to, you use the digit beside it. If it's 5 or above, then you go up. If it's 4 or below, then you go down. So in this example, we want 1 decimal place. We look at this 1. The 7 is greater than 5. Our answer is rounded to 0.2. For the second example, we have 2 decimal places versus 3 decimal places. We end up with 2. For rounding, the 2 will become a 3 because of the 5. The next set that we'll look at are the division and multiplication, C and D. Still apply the rules for significant figures, and then round each answer to the appropriate number of digits. Multiplication and division is usually more straightforward. For multiplication and division, you will look at both, or however many variables you have, and look at their total number of significant figures and use the lowest. 13.5 has 3, 45.18 has 4. When you plug this in your calculator, you get this long value. This will be rounded to 0.299. To get 3 significant digits, this leading 0 is not significant. 2, 9, 8, but the 8 becomes a 9 because of the 8 beside it. Part D. 6.25 is 3 significant figures. 1.175 is 4 significant figures. Popping these in your calculator, you get this digit. You will round to 7.34 because of the 3 significant figures. It stays a 4 because beside it we have a 3. One other thing that you want to wrap your mind around is paying attention to units. When we start looking at word problems and conversions, you'll want to pay attention to how the units cancel if they square or cube. This first example, we have grams divided by liters. These are different units, so they both remain. In the second one, we have centimeters times centimeters, so those end up being squared. For addition and subtraction, the units need to be the same. You need to have a centimeter minus a centimeter, or a squared centimeter plus a squared centimeter. You can't add a squared centimeter to something that's in centimeters, and so forth. Now let's take a look at part E. Again, apply those same rules of significant figures and calculations and then round your answer. This is looking at scientific notation. So with the scientific notation, you do want to make sure that you plug it into your calculator correctly. Do ask me for help or look up how to do it correctly. Your calculator will do exactly what you tell it to, and it can be plugged in incorrectly. So, when you have this in your calculator, you should get back out 55.37 times 10 to the 2. We have 1, 2, 3, and 1, 2, 3, 4. We're adding these together, so we want to end up with 2 significant, or 2 numbers after the decimal place. So this answer has 5.537 times 10 to the 3. They did a couple things here all at once. They've changed the 55.37 and moved the decimal place 1 position to the left. Usually scientific notation only has 1 non-zero digit on the far left, and the decimal is right after. So while this is correct with your 2 digits after the decimal place, usually scientific notation does move that decimal. So then when that decimal is moved over 1 place, this becomes 10 to the 3. The significant figures were determined from this initial answer. So when you move the decimal place, you will not change any of the digits, even though this does become 537 after the decimal. Now, it's getting pretty picky. If you did have 5.54 and you have the 2 digits after that decimal that still has the 2 digits after the decimal in the given answer, and that would be fine. So with that, with this situation, I think there's a little bit of leeway. Okay, so all right, now that we have a good idea of practicing significant figures, using those in mathematical operations, let's start to look at word problems. This reads an empty container with a volume of 9.850 times 10 to the 2 cubic centimeters is weighed and found to have a mass of 124.6 grams. The container is filled with the gas and reweighed. The mass of the container and the gas is 126.5 grams. Determine the density of the gas to the appropriate number of significant figures. Okay, if you need a strategy, this problem requires 2 steps. There's subtraction to determine the mass of the gas and division to determine its density. You'll want to apply the corresponding rule regarding significant figures to each step. So, for the solution, first part we want to do a subtraction. 126.5 minus 124.6 comes out to be 1.9. Notice the 1 decimal place past the, or 1 digit past the decimal place. That's going to give us a total of 2 significant figures when we apply the decimal rule for the subtraction. Next is density. Density is mass divided by volume. And it's always mass divided by volume. You'll use your mass of 1.9 grams, the volume of 9.850 times 10 to the 2 cubic centimeters. You can notice how the centimeters are cubed. Volume does have 3 dimensions. Working this out on the calculator, you should get something in the range of 0.00193 grams per cubic centimeter. You'll round this to 0.0019 grams per cubic centimeter. The leading zeros are not significant, and the 3 does not change the value of the 9. If you think about this, although we have 3 numbers we started with, or it says in this case, although each of the 3 numbers we started with has 4 significant figures, the solution only has 2 significant figures. So it's kind of a trick, and the trick comes from remembering the addition and subtraction rule, looking for that lowest number of decimal places. I'm going to go ahead and stop this second part of the video. Thank you.